Welcome back to our system design series. Today we are going to explore a key concept in distributed systems, strong consistency versus eventual consistency. Understanding the trade-offs between these two types of consistencies is crucial for design systems that meet your specific requirements for reliability, speed, and data accuracy. So let's start by talking about an example, and in this example we'll try to understand what each one of them means. So let's say that we have multiple clients. Okay, we have four clients. Okay, we have client one and client two and client three and client four. Okay, so we have four clients, and these clients are sending requests to our application. And let's assume that our application might sometimes have a strong consistency and some other times could have like eventual consistency. Okay, that's great. Let's do it like that. Okay, so let's assume that right now our application have a strong consistency. Strong consistency ensures that any read operation returns the most recent write for a given piece of data. This means that once a write operation is acknowledged, all subsequent reads will reflect that write. In other words, the data remains synchronized across all nodes and users will always see the latest version of the data. Okay, what this means. Let's assume client one, let's say that we have a product and called P. And client one updated this product P. Okay. And when client one updated this product P, all other clients try to read this product, they will read the last version. So basically, they will read what client one edited or edit. Okay, so we will make sure that all the nodes or all the clients are reading the same product at the same time. There is no delay whatsoever. We have a strong consistency. So whenever an any write have been happened to any record of the database, all of the other clients or nodes will can read the exact same node and exact same data. It's pretty simple. And the pros of this one, we have data accuracy because users always see the latest data, ensuring data accuracy and reliability. And the other thing, we have predictable behavior because applications behave predictably because every read always returns the most recent write, making it ideal for scenarios where accuracy is critical. The cons of this one, we have increased latency because achieving a strong consistency often involves ensuring all nodes are updated before acknowledging a write. This can lead to increased latency, especially in geographically distributed systems. So when client one trying to add the product, basically our application might be is, let's assume our application is a distributed application that is has a lot of different data centers across the globe. So it will make sure that the product, the updated P is updated onto all the data bases centers. So all the other clients will read the exact same P or the exact same product or the exact same data. The problem of this one, we said that we have increased latency because this takes times. The second thing, we have some sort of scalability limitations because strong consistency can be harder to achieve at scale, as every write must be propagated to all nodes before it can be considered complete. The second thing that we will talk about, which is eventual consistency. So eventual consistency ensure that given enough time, like all nodes in the system will eventually coverage to the same value. However, there are no guarantees about when this coverance will occur. This means that in the short term, different nodes may return different values for the same data, but over time they all need to coverage to the data correct state. So let's take the same example. Let's say client 1 updated a product called P. So maybe we have a client 2 and client 3 and client 1. All of these three clients are from Germany. So they are connected with a German data center. So they can read the exact same thing or the exact same updated P or updated product. However, let's assume client 4 is in France and it's connected to a France database center. So it might not have the ability to read the same updated P as it's the latest version, because it might have some sort of delay. Like a good example of eventual consistency is like a social media feed. Like when you post a new update, it might take some time for all of your followers to see it, depending on which server they are connecting to. Over time, all servers will coverage and everyone will see the most, but there might be some temporary inconsistencies. We can talk about the pros and cons of this one. The first thing, it's high availability, the first pro, because eventual consistency allows for higher availability since nodes doesn't need to wait for every other node to be updated before accepting reads or writes. The second thing, we have a better performance because with fewer synchronization requirements, systems we're using eventual consistency can achieve lower latency and better throughput. The cons of this one, we have a temporary inconsistencies because there may be times when different users see different versions of the same data until all nodes are coverage, um, which might be not acceptable in certain use cases like financial transactions, for example. The second thing, we have unpredictable timing because there is no guarantee on how long it will take for the data on coverage across all nodes, making it quite unpredictable. Okay, so let's answer the question: when to use what? When to use strong consistency and when to use eventual consistency. You could use a strong consistency is ideal basically for scenarios where accuracy is critical and users must always see the latest version of the data, such as financial applications, inventory management, or booking systems. If we have eventual consistency, it's good fit for applications where availability and performance are more important than immediate consistency, such as social media, messaging apps, or content delivery networks. So yeah, that's it for this video, and I hope you like my content. If you like my content, make sure to subscribe and hit the notification bell so you'll never miss any video, and see you guys in future problems.